This video is going to cover Section 1.3 regarding more information about functions. Now you'll notice that I've crossed off target 1.5, the evaluating and simplifying a function's difference quotient. I've decided to throw this target out this chapter since we won't be needing to know how to do this until chapter 11, which is in trimester 3. So we are going to throw out target 1.5, and this means that you can cross off the first page of section 1.3's notes. You can cross out the part where it says difference quotient, piecewise functions, and step functions. So go to the next page where we're going to talk about finding key information from graphs. So looking at a graph, there are many different things that you will be able to find or look at. We are going to need to know intervals where the graph is increasing, decreasing, and constant. We need to be able to find x-intercepts and y-intercepts. Domain and range we did in section 1.2. And then we'll also need to look at a graph and see if it has any relative minimum or relative maximum. So points where it has, something that looks like a vertex of a parabola. So the first part of this is finding the intervals where the function is increasing. So just looking at the graph, where is the graph going up from left to right? You can see your axes on your notes, mine are covered up, but it looks like it starts to increase at an x value of 2 and it stops increasing at an x value of 3. So I'm going to write the interval like this with parentheses, so 2, 3. Now I know it looks like a coordinate, like an xy point, but it's not. This is an interval. From 2 to 3, my graph is increasing, and then I have parentheses around it, not a square bracket, because it doesn't include the endpoints. Since you can't increase at a point, that's why we use parentheses, because it doesn't include 2 and 3. It just means it's going up between 2 and 3. Where the graph is decreasing, it looks like it starts at 0 and it goes down until you get to 2. So once again, this is not a point, it is an interval of values. So an x value of 0 to an x value of 2, the graph is decreasing. And then lastly, where is the function constant, meaning where is it horizontal, where it has absolutely no slope. And it looks like it starts at 3, and since the graph has an arrow at the right, it goes to infinity. And so you'll see here that this looks a lot more like an interval because it has an infinity and it's not a coordinate. Another point that we're going to be able to decipher on a graph is relative minimums or relative maximums. And this is a relative minimum is where the graph goes from decreasing to increasing. And this is a point now. Now we're not talking about an interval. And so looking at this graph, is there a place where it goes from decreasing to increasing? So yeah, it looks like it has a vertex down here, and according to the axes, it looks like it occurs at 2 and then about 98.5. A relative maximum is a point where the graph goes from increasing to decreasing. Now in this graph, we don't have a relative maximum because we don't have any place where it goes from increasing to decreasing. So there is none for this particular one. Other key information that you'll need to be able to find from graphs would be x-intercepts, y-intercepts, and then the next part that we're going to talk about is whether a function is even or odd. So an even function is even if you can plug in a negative x value and it comes out as positive for all x in the domain of f. And this just means if you have an even function that the graph is symmetric with respect to the y-axis, meaning that it folds onto itself vertically. And then another way to decipher if a function is even is if you have xy on the graph, then that means negative x, positive y is also on the graph. And we'll go over a couple of examples of how you can find this when you're not given the graph and when you're just given the equation. When you're given the graph, all you have to do is look and see if you can fold it on the y-axis, then it's an even function. An odd function is one that if you were to plug in a negative x value, the negative y value comes out. Or I shouldn't necessarily say negative, but the opposite y value comes out. Odd functions are also symmetric with respect to the origin. And this means that you can rotate the graph 180 degrees and it falls onto itself. So there's no folding involved. It's all about rotating it 180 degrees. And so this means if xy is on the graph, then so is negative x and negative y. And so on the next page we have our examples of how we can find an even or an odd function using the equations. So the first example I have, let me cover those up. Is f of x equals x cubed minus 6x. And so what we're going to do to check to see whether this is even or odd is to plug in a negative x value. And if all the terms signs switch, so if x cubed becomes negative and negative 6x becomes positive, then it's an odd function. If the signs stay the same, then it's even. And then if one sign changes but the other one doesn't, it means it's neither. Now you cannot assume that just because the exponent on this polynomial is odd that it's an odd function. So you always have to do the work to check. So plug in a negative x wherever we see our x value. So negative x cubed minus 6 times a negative x. Simplify the function. We get negative x cubed plus 6x. Since both signs changed, the x cubed went from positive to negative and negative 6x went from negative to positive. This is an odd function since all of the signs changed in the equation. Our next example is x to the fourth minus 2x squared. So we're going to determine whether this is even, odd, or neither. So we're going to plug in a negative x value. So you get negative x to the fourth minus 2 times negative x squared. When we simplify this, we get x to the fourth minus 2x squared. Now nothing changed in the equation, so this means that this is an even function. So our example A was an odd, example B was even. And then our last equation is h of x equals x squared plus 2x plus 1. So now we're going to check by plugging in a negative x value. When we do that, we get negative x squared plus 2 times the negative x plus 1. When we simplify this, we get x squared minus 2x plus 1. Now you'll notice the first sign, or the first term, stayed positive. The second term went from positive to negative, and the third term stayed positive. Since not all of the signs changed or stayed the same, this means that this function is neither even nor odd. And then the last thing I have is another example of finding all the key information from a graph. I have added this page to the notes in Moodle. Otherwise, you can pick up this page in class on Monday. So what I want you to find is all of this information using this graph. So go ahead and pause the video, find these this bits of information regarding this graph, and come back and check your work. So the first thing, finding the x-intercepts. X-intercepts, remember, is where the graph hits the x-axis. There can be more than one. There might just be one, or there might even be none. But in this case, the graph hits at negative 6, 0 and also at negative 2, 0. Y-intercept is where the graph hits the y-axis. Once again, there might be none, there might be one, there might be more than one. And in this case, there is only one y-intercept, and it hits at 0, negative 4. The next part we want to look for is intervals of increasing. So now what x values is this graph going up? And so if you're starting from left to right, it looks like it's increasing from negative 6 to negative 4. And then again, it increases from 0 to 1. And so remember, these are not coordinates, these are intervals. So from an x value of negative 6, and this should say an x value of negative 4, not a positive 4, and then from 0 to 1. And then this function is decreasing from negative 4 all the way to 0, and then once again at 4 to infinity. So we're looking at x values again. So this is not looking at y values. It's decreasing from an x value of negative 4 to 0 and a positive 4 to infinity. And then where is it constant? Where does it have a horizontal line? This graph is constant from x value of 1 to an x value of 4. A relative minimum, remember a minimum is where the graph goes from decreasing to increasing. And so on this graph it went from decreasing from -4 to 0. So at 0 it's going to change from decreasing to increasing. So we have a relative minimum at 0, -4. And then maximum is where it goes from increasing to decreasing. So we have a maximum at -4, 1. And then the last thing is the domain and range. This is from section 1.2. How far left and how far right does the graph go will give us our domain, -6 and then all the way to a positive infinity. And so you can write it as -6 is less than or equal to x is less than infinity. And then range is how low does the graph go to how high? Well, it goes from -infinity up to a +1. And so this video covered section 1.3, and all you have to worry about is just identifying key information from graphs, anything from the slope, from where it's increasing, decreasing, constant, whether it's even or odd, and x-intercepts and y-intercepts.